Welcome Year 6 to your daily maths lessons. These first 6 to 8 lessons will all be centred around area and perimeter and volume. You will need a pen and paper or a whiteboard and pen. You shouldn't need to have anything else in front of you. Okay, continuing our theme of area and perimeter, just to quickly recap, the perimeter of a 2D shape is the distance travelled around the outside of that shape. So you add up all the sides of that shape to give you the perimeter. The area of a 2D shape is the space that that shape takes up, so it's the inside of that shape. So today we're going to be looking about how we find the area of triangles. So thinking about the space a triangle takes up and how we work out the area of that. I'm not just going to tell you that today. This lesson is about you discovering that for yourself. So the first thing I'd like you to do on your whiteboard or paper is draw a rectangle with a width that has 5 centimetres and a length of 6 centimetres. When you've done that, I'd like you to write the area of that rectangle. Remember in your learning from yesterday, the area of a rectangle is length times width. So draw that rectangle as described on the screen and work out the area. Okay, you can pause to do that. When you've done that and you've resumed, I'd then like you to draw a right-angled triangle with a height of 5 centimetres and a length of 6 centimetres. Okay. Once you've drawn that on the same page, so you can see and you can compare it to the rectangle you've drawn, have a think about that question there. What is the area of that right-angled triangle? How does it compare to the rectangle that you have drawn? And knowing what you know about the area of the rectangle, can you have a think maybe about what the area of that right-angled triangle might be? We'll have a look at that together now. Okay, so you should have drawn something like this. A rectangle with a width of 5 and a length of 6, and a right-angled triangle with a height of 5 and a length of 6. And then I asked you to look at the areas for both of these. We know how to work out the area of our rectangle. We know it's length times width. So 5 times 6, length times width, 5 times 6, 30 centimetres, and it's squared because it's area, 2 dimensions, it's squared. If we look at how we might work out the area for this right-angled triangle, remember it's the space that these shapes take up. So this is the rectangle, this is the right-angled triangle. Can you notice anything about these two if you compare them to each other, how much space they take up? If I was to do this, maybe this would help you, okay, having a look at those. Now you might be able to see, hopefully, that this right-angled triangle would fit in here. So this right-angled triangle would be half the size of the rectangle, or in other words, it would have half the area of the rectangle. So we would expect this triangle's area to be half of the rectangle's area. So we would think that this would be 15 centimetres squared because it's half that of the rectangle. Okay, so we saw that the right-angled triangle we just drew was half the size of the rectangle. I wonder if that works for all right-angled triangle. Try and draw this one and see if the same happens. So a rectangle with a width of 4 centimetres and a length of 7 centimetres. Work out the area. And then draw a right-angled triangle with a height of 4 centimetres and a length of 7. And what would the area of that one be? Okay, do that, then we'll have a look at that together. So let's look at this exactly as we looked at the one before. We've got the rectangle up here. So the area of our rectangle is length times width. So 7 times 4, which is 28 centimetres. It's area, 2 dimensions, so it's squared. So the area of our rectangle is 28 centimetres squared. Our triangle, does it fit? Is it half? You could also see like this. that it would be half of a rectangle. It fits in here exactly half, or if you made this into a rectangle, you can also see the right angle triangle is half of the rectangle. So if it's half of the rectangle, then it would be 14 centimetres squared for the area of the triangle. You can have a go with different right angled triangles. You can put them up in different ways until you can see, hopefully, that the right angled triangle is half of the rectangle. Therefore, to find out the area of it, you're going to be thinking about half of that area. Right, so if you've experimented with a few of those, you will see that right-angled triangles are always going to be half of a rectangle, as is shown on the screen there. Can you maybe think now of a sentence to describe that relationship between the area of the rectangle and the area of a right-angled triangle? Can you come up with like a rule, a sentence that describes that relationship in relation to the area that both of those shapes take up? Maybe write that down on your paper. Right, so using the sentence that you just wrote to describe the relationship between a right-angled triangle and a rectangle, can you think of a mathematical formula that you could write to describe that relationship? So rather than using words, could you maybe put it into a formula of how you would describe the area of a right-angled triangle? Looking at the shape on the screen then, once you've written your formula, have a think, does it work for this? So I've given you a rectangle and I've given you the green triangle within it, and I've given you the numbers 4 and 7. They can be centimetres, metres, whatever you want them to be. But what I want you to do is write your formula and then put those numbers into it, and do they work? So when you use that formula, when you work out the triangle and you work out the rectangle, is your triangle half your rectangle? Does your formula work? So you're coming up with a formula and then you're trying to prove that it works. Okay, so test that now. Write your formula. We'll have a look at this at the start of the lesson tomorrow. We'll go through all the formulas you can use for triangles. You can check if you're right. But for now, just test it yourself. See if you've come up with a formula that works for the triangle, that it's half the area of the rectangle. You can try other triangles too. You can draw some out for yourself. Can you come up with a written mathematical formula for the area of a triangle and test it on that? Okay, we will resume with the area of triangles 2 tomorrow, and we'll start with this.